I don't know what got into me, both my wife and I, but back in the mid 2000s, we came across this information that Oregon has a bunch of covered bridges, and they're built from maybe a little after 1900 all the way up to um, maybe even as late as the 1960s. Sometimes they were rebuilds, but there originally were 300 covered bridges in Oregon. Now there are 50. There is one that is a railroad covered bridge that is actually, it was so derelict that we couldn't even get close enough to it to get a good look at it, but they've since rebuilt it, and it's down uh, in Cottage Grove, Oregon. And so that's one that you can easily visit if you're going up and down the I-5 corridor. Matter of fact, there are a lot of these are relatively close to the I-5 corridor, but we got it into our minds that, hey, we really love traveling through the back roads because there's usually a lot of pretty scenery and so forth. And I'm a kind of a sometimes on and off fly fisherman, and so we spent a little bit of time over 2 summers back in 2007 and 2008, traveling around and taking a look at these covered bridges. And of course, being that I'm an architect, uh, I like to document things. And so I went through and with my wife's help, my wife Nancy, we actually measured up all of these covered bridges, and of course took a lot of photographs. And I have in this presentation 26 of those 50 that I'm going to quickly go through and tell you a little bit about. And I'm also going to share um, share I guess you could call it some just general information about how covered bridges are generally built, at least in Oregon, I presume in other places as well. The whole notion of a covered bridge is that a wooden truss bridge, which most all of these are, there's only one that isn't a wooden truss. It happens to be a steel truss, and actually it's the ugliest one of the bunch. But anyway, um, uh, they require some protection because wood tends to rot, particularly in the wetter climes of Western Oregon and of course Western Washington. Now you might ask, did Washington ever have any covered bridges? Well, I'm only aware of one existing covered bridge, and it's down just north of the Columbia River near the town of Nacelle, and it's on kind of a back road down there. And I won't get into that, but there is one that's a little bit closer than going all the way to Oregon, but not a whole lot closer to us here in South Puget Sound. Um, so anyway, I'm going to just go through some pictures as well as some drawings of these, and you can see that there are a lot of similarities, but there's also a lot of variation in terms of how they look. Anyway, here's a map of mostly Western Oregon, and that's where most all of these are. The most easterly one is over in the Bend area, and it's actually in pretty tough shape, so it's almost not worth visiting. But this website here, this www.coveredbridges.org, used to be a little bit more helpful way back when, but you can still get information on it. But if you look carefully at this map, you can see all these little rectangular names here. Those are the names of all of these covered bridges. And like I say, there are 50 of them. And so I'm going to kind of walk you through these, and so you can kind of see what they look like. So here's one. This is this is Cabot Creek. Now I'm going to tell you a little bit about where these are. This is 23 miles east of Roseburg, Oregon, and it's a relatively narrow bridge. And you can see how there's usually roof trusses and siding and so forth. And sometimes there's windows, viewports that you can look out. Sometimes they're not. So this is a drawing, and these are virtually all Howe style trusses. And I'll get into kind of how they work, pun intended, later on. And but you can see some of the dimensional information. You see this one, the opening on it, it's only a little over 16 feet wide, and so you're not going to get two cars going side by side through there. at least not comfortably. So here is Coyote Creek Bridge. Now, a little bit better view on the inside of this one. Coyote Creek is located west of Eugene, about 7 miles. It happens to be 60 feet long as far as the actual span, not including the approaches on it. And this is a little sketch. And you can see down below here on this drawing kind of how the trusses are set up. Most of these have a 15-foot bay for the structure. And so what by bay, I mean this, this point to point where this is. This one happens to be a little bit wider than the last one. This is the Curran Bridge. It's 4 miles east of Cottage Grove. There's quite a number of them in and around Eugene and the Cottage Grove area, as well as up near Salem and Albany as well. And here you can see that this used to be the main bridge over the waterway here, but they've since built a new bridge right next to it, and so this has been turned into just a pedestrian bridge here, and which is the case on a number of these. But there are still a lot of them that are being used as car bridges. So here's a drawing of it. Once again, not terribly wide. And this line right here, this is the center line of the bridge. So we've got 1, 2, 3, 7 total bays on this one. So this is 105 feet in length. So this is a Deadwood Bridge. This is west of Eugene, kind of back in the sticks in the coastal range here, and it's about 64 miles west of Eugene. Some of these bridges, when you're going to see them or travel between them, you get through some quite back roads. Matter of fact, there was a couple of times I thought I was hearing the banjo going as I was traveling through these some of these back roads, because there's a lot of people that live off the grid in this coastal range in Western Oregon. You'll see no power lines, no telephone lines, nothing like that, and they're just out there, and so it's interesting. So this is a 135-foot span on this particular bridge. See kind of what it looks like. So this is wide enough for 2 vehicles to pass here. Here's another little bit wider one. This is located, the Darina Bridge. It's located 12 miles east of Cottage Grove, and it's a 90-foot span. And of course, one of the things that you'll note is that all of them have these interior guardrails, so that if you happen to lose track of where you're driving, that you're not going to tear out the structure of the bridge as you're passing through here. And as I mentioned, I fly fish, and some of the creeks that these things go over, really picturesque, really pretty places to visit. And if you like traveling back roads, you're going to be in luck. Driving around the countryside. So some of them have kind of a shuttered sort of openings on the sides here, like this shows, and some of them are just open and allows the wind to blow through. And this is what it looks like here, given some dimensional information. This is one of those situations you wonder, how did I get up there and measure all that stuff? Well, you know how we take photographs and we manipulate them to use a scale and enlarge, taking known dimensional information. Well, that's how a lot of these dimensions were gathered from taking good photographs. And I actually brought a ladder along so I could get up as high as I could. So I'm looking kind of as much as I can straight into the middle of these end elevations, and so I didn't have as much parallax or perspective distortion, if you will, on the photographs that I was taking. And of course, I had a good quality SLR camera to do this. This is the Gallon Bridge. What's interesting about this particular bridge, it's 15 miles northeast of Salem, but it's between two communities. One community is Mount Angel, and the other community his name escapes me right now, but Mount Angel was allowed alcohol, and the adjacent community on the other side of the creek that this crosses was a dry community. They didn't allow any alcohol, and so this was a place where people would come and get their booze and go home with it. So that's the reason why it's called the Gallon Bridge. Here's some drawings here of that one. Yeah, this one's 84 feet long. You can see the decorations in terms of, how the end elevations are shaped, and these portal shapes vary a little bit from bridge to bridge. Here's the Gilkey Bridge. This is located 10 miles from exit 238, which is just a little bit north of Albany, I believe. So it's southeast of Salem. And it's 120 feet long. So it's one of the longer ones. And you see how nice and open this is on the sides. It's to show the structure as you're passing through. It's really quite nice looking bridge, and I'm sure it gets a little bit more weather penetration on the wood structure than some of these other ones that are more enclosed, but it's very nice looking. So you can see how proportionally long it is in the shape of the end elevation. So this is the Hannah Bridge. Hannah Bridge is located 22 miles northeast of Albany, and it's 105 feet long. And once again, pretty open on the sides. My ability to photograph I'm going to call it the water sides of these varied quite a bit, depending on how thick the brush was and trails to get down to the river or off to the side to take these photographs. One of the things that's a very common characteristic is there always seem to be some sort of protective, I'm going to call it a wainscot, here as you enter the bridge on either side, probably dealing with the water being splashed by the vehicles as they enter from either end of the bridge. There's a drawing of that. Like I mentioned, this is 90 feet long and has the typical 15-foot bay width. Here's the Hoffman Bridge. Hoffman Bridge is located 14 miles east of Albany, Oregon, and it's 90 feet long. And was able to get down and get a nice view of it from down near the creek elevation. But very picturesque location here, like most of them are. It's a sketch of the structure. Horse Creek, this is further south. It's near Myrtle Creek, Oregon. It's actually in Myrtle Creek. Not that Myrtle Creek's a very large community, but you just take one of the roads through town and you can see this. It's 105 feet long and fairly open, as you can see, but it has more lower viewports out the side. As you're driving through, you can look out of the bridge. Here's some dimensional information for you. See, it's just a relatively narrow roadway through here, so you're not going to put more than one vehicle through there at a time, at least not a four-wheeled vehicle. the Larwood Bridge. This is 17 miles east of Albany, Oregon, and it's a 105-foot span. Once again, more open than some of the rest of them. You know, picturesque it is with the creek or river running through there. Many of these had these nice arches like this with the flared splayed sides on them, made for a very nice proportions. This is a pretty cool bridge. It's not used as a vehicle bridge anymore. You can see off to the left of this view that there's a new roadway that goes through here. But this has been kind of turned into a little museum, if you will, that talks about covered bridges in Oregon, and they have a really beautiful cutaway model of the bridge. So you can kind of see the major components and so forth. And it's, you know, it's obviously been restored and is in really good shape on the inside. And it's quite long. It's, I believe this is 165 feet long. So it's quite extensive. And it's 21 miles southeast of Eugene. You note that most all of these that I've mentioned are all, well, most, maybe not all, but most within a pretty easy side trip off of I-5 if you're traveling up and down that corridor. And if you just wanted to say, hey, let's just take off and go see this bridge or that, it's not all that tough to do, although you do need to get directions for them because they're not generally on or near major highways. Sometimes they're kind of circuitous routes to get there. And there's a view of the end of that guy, and it's nice and wide. It's 24 feet wide inside the portal there. Milo Academy. This is the ugliest one of the bunch. I just wanted to show you that, you know, they're not all terribly elegant. This is down further south in the state, and it is oops, sorry, got to go back to my notes. I went the wrong way here. This is 16 miles east of Canyonville, Oregon. So it's not quite as far south as what's that called? Grants Pass. It's just south of Myrtle Creek, off to the east. And this one happens to be a steel truss. It's actually a kind of a combination of a girder, which runs across like this, across the bottom. And then they built some structure over the top of this to give it some more stiffness, I guess. And so when you go back to the previous picture, you can see here's this steel plate girder on either side like this, and then they have this top cord and then a post in the middle of it on either side. And like I say, this I think is kind of the ugliest one of the bunch, but you can kind of see what they did. It is covered like the wooden ones, but its main bridge structure is steel, although the deck and the roof covering and so forth are all wood. Mosby Creek is 5 miles southeast of Cottage Grove. Somebody's dog is barking. This is a 60-foot long bridge. Oh, I didn't note, but the Milo Academy one, the previous one, it's 100 feet long. The Mosby Creek here is 60 feet long. So it's one of the shorter ones. One of the things that's interesting here, you can see I've shown where the basic roadway elevation is, but sometimes the approaches ramp up to it significantly. And so the sides of the bridge that come down and can cover the buttresses will extend down, well, here in this case, over 6 feet on either side of the entry. But it's a pretty short span at only about 60 feet. Neal Lane. Neal Lane is located 1 mile southeast of Myrtle Creek. So it's in the southern portion of the state. And this one, as you can see, they lost confidence in it and decided that they'd better put some additional structure underneath of it. So even though it's not a very long bridge, it's only 42 feet long, apparently it's a little worse for wear. But it's kind of a cute little structure. As you can see, it's just a kind of a single, or actually just a double bay with just a simple A-frame truss. So that might be one of the reasons why they had to put some additional structure underneath of it. If it had a third bay in there or something like that, it might have been a little bit stronger. Nelson Mountain Bridge. This is 39 miles west of Eugene. It's a little further away. And it is 105 feet long. So it's one of the longer ones. But once again, not terribly wide, really only one vehicle width. And so you'll have these signs that as you're approaching these bridges that warn you about this. And so usually you can see through the bridge and see if somebody is coming through on the other side, and they give you enough room there to pull off and before you approach and so on. It seems to me there was one of them that actually had lights on it, so if you came up, there was a stop light. It might have been just because the approach to the bridge was really, really curvy. This is an interesting one in its location. Well, first of all, it's got this side walkway that goes through, and as you can see, it's fairly significant trusses here. But this particular bridge is located. Oops, let's go the right direction on my notes here. This particular bridge is 43 miles southeast of Eugene along the UP right-of-way. So this is west of the summit of the railroad, but it's right next to the big yard that is here. So you can do some train watching while you're taking a look at this covered bridge. This is, of course, a vehicle covered bridge rather than a rail one, but it's pretty long. It's 180 feet long, but it's in a neat location, and for us train folks, it might be one worthwhile to travel to see. Relatively narrow, but you can see here's the center line right here, so it's got quite a number of bays. Parvan Bridge, this is 21 miles southeast of Eugene, and it's got a 75-foot span. Here's an example of signs warning you that it is one lane, and weight limits, of course, pretty typical. So most all of these have got wood decks here, and I'll explain how those are constructed as we get close to the end of the presentation. Pass Creek. This is located in Drain, Oregon. Everybody remembers where Drain is, don't you? drain is, it is just off the beaten path, just south of Cottage Grove, a few miles. And this is 61 foot long. Another single lane bridge. The Pengra Bridge is 20 miles east of Eugene, and that's one of the longer ones at 121 feet. But what was nice here is the ability to crawl down underneath and get a really good look at how the structure is put together underneath that supports the roadway. And some of these, let me go back up. Some of these, instead of having viewports down below, they had these clear stories, you know, just a clear story opening up high. That's actually better protected than if they were down low, because the roof overhang typically gives them some protection and still gets you daylight in there, so it's not like going into a tunnel. So here's one that got a relatively new metal roof on it. This is the Rochester Bridge. Oh, keep doing this wrong. So the Rochester Bridge is located 2 miles northwest of Sutherland, Oregon. And let me think of where Sutherland is. It's, yeah, it's down, well, kind of halfway between Roseburg and Cottage Grove. So just off of I-5. Matter of fact, all of these locations that I've given you the city that's basically on or really, really close to I-5. So you get a sense of how convenient it might be to go and visit. This one was kind of neat in that you can see here, sometimes they would envelop the truss structure on the side and have this sill piece, if you will, that was integrated. And so if the rain blew in here, it would shed back out of these openings. And then here, of course, is the guardrail that runs on the inside of the structure. And this one is wide enough for 2 vehicles barely. It's a little narrow, but it you know, you seem to be able to get through there with two cars abreast if you take it slow. Shamanic Bridge is located 15 miles from exit 238, which is northeast of Albany, Oregon. This is one of the longer ones at 130 feet. And as you can see, both lanes run nicely through this bridge. And it has these kind of shuttered openings in the side to help keep the rain out. And that's what the end view looks like in the sketch form. So you see it's 23 feet clear as you're going into it. So about as wide as a typical county road. State and Jordan Bridge is southeast of Salem, about 15 miles. And this is actually in a park. And so there's, oops, where did that come from? So there's a portion of the park on one side of the creek and a portion of the park on the other. The parking is over on that side over there, but very, very nice, you know, place to get out of the weather if rain hits you when you're in the middle of a picnic. and you can enjoy the creek as it runs through. This bridge is 90 feet in length, and it's relatively wide. Sounds like I'm putting somebody to sleep.
Not really.
Well, there's a lot of bridges here. Like you can see, there's a lot of similarities, but then there's also other characteristics too that are different. This is Stewart Bridge. It's 5 miles southeast of Cottage Grove, and it's one of the narrower, smaller ones. And of course, it's been replaced by a concrete girdered roadway that crosses the creek here. So this is just a pedestrian or bicycle, if you will, bridge. And it is 60 feet long, so it's one of the shorter ones. And I believe this is the last one that I've got pictures of. Yes. No, one more after this. This is the Unity Bridge. It's 23 miles east of Eugene. It's fairly close to a previous bridge that I showed you, the Lowell Covered Bridge. It's just a couple miles from there. And once again, this how truss style, and when they're in uneven number, they'll do this crisscrossing of the members, which looks pretty cool actually. But this is one of the wider ones. And then we have the Wildcat Bridge. This is 34 miles west of Eugene. Most of the bridges are on the east side of the I-5 corridor, but this one is on the west side. It's 76 feet long. And some of these have got, long approaches like you see here. And sometimes they're spans like this, and sometimes they're a trestle sort of arrangement as you approach the bridge, depending on how wide the valley is or the canyon that you're crossing to get to the bridge abutments. So one of the narrower ones. Okay, let's talk a little bit about the components of these covered bridges, at least the wooden ones. So, that a wooden bridge like this has basically got a truss on either side of the bridge, and then you've got the deck that goes in between. And if you'll look at what I've shown here, is that these diagonals, these are the wooden members like this. So there's these diagonal wooden members. And when you see these arrows coming, see how they're kind of pointing towards one another? That means that these are in compression. So these are trying to be foreshortened, if you will. So these are all in compression here. This top cord is also in compression. It's trying to get, squeezed like that. The bottom is in tension. So it's being pulled apart. And then all these verticals here, these steel rods are all in tension. And of course, something that's in tension will maintain its axis without any problem. Things that are in compression tend to want to buckle. And so they've got to be beefier. And so that's how these things generally work. And so here this span is going from this abutment to this abutment, and this is kind of how all these things are working. And of course, because these are supporting both a roof as well as a driving or walking deck, then you need to tie these together. And of course, just as a truss, it was just a single truss that was spanning across the creek or river, then it would be fairly unstable, because it is just a tall, gangly sort of a thing. And so these horizontal elements that go between the top cords of these two trusses, and the bottom chords of these two trusses help keep them stable. And so we see here on the top, we've got bridging that goes between, and as well as diagonal bracing that goes there. And I'll give you some other illustrations of that. And then on the bottom here, to support the driving deck, you've got these deck support beams that go, whether it's 15 or 16 feet, all the way to the 24 plus feet in width, depending on the width of the roadway. And then there's diagonal braces that are underneath here as well that help stabilize this cage so that it all works as one structural element. So here's a cross section looking through the bridge. And so these are these top and bottom chords of the trusses here on either side. And then below the truss, you have this, there's a beam that is basically hung off the bottom of the truss. And usually it's done by running this steel rod, these tension members, all the way through to the bottom of these beams here. And then there's also members across the top, of course, because they're not supporting the heavy loads of a vehicle. They can be much smaller, but you have these bridging and diagonal braces running across the top. And to keep this whole thing from wanting to turn from a rectangle into a parallelogram, then you have to add diagonal braces here to keep the structural elements stable. And down below, besides these beams, of course, you've got to get some decking and some joists that go between these beams, which are typically, these beams end up being at those structural bay points, which generally are about 15 feet apart. So you've got these joists that are, anywhere from, I think I saw them as close as about 12 inches up to 24 inches apart. And these are of varying sizes, depending on the bridge. Now, if you were to take a top-down view of the quote, the roof, not the actual roof, but the top of the truss, you have, here's the truss on this side. Now you've got these beams that go across between, and then you have the diagonal bracing that are let in like this, and then these diagonal struts that were mentioned. And those are typically, although not exclusively, but typically they're at the openings of the end of the bridge, or at least on the last bay. And then if you were to look at the actual driving deck, then you've got, once again, the bottom chord of the truss like this. Got these big beams that go across. And then you've got diagonal bracing that goes between them to stabilize all this. And then resting on top of those beams are these joists. And then the decking that goes across like that. And sometimes on top of the decking, they'd have additional boards where the wheels would actually be running. And those would help cut down on the wear and tear and probably the impact loads on the decking as well as a vehicle hits the bridge, because there's a dynamic load that occurs when all of a sudden, the bridge is just there with only its dead load. And then all of a sudden you've got, however many tons that are landing on one end of the bridge and moving across through the bridge. So they try to distribute those dynamic forces through the bridge or through the deck. And then of course, because as I'd mentioned from the onset, these wooden elements, structural elements, all need to be protected from the weather. And so there's usually an exterior skin, if you will, some sort of siding and some horizontal beams usually that run along. And then at openings, they'll protect the adjacent structure with some sort of a sloping sill element. And then they'd run a separate wood truss across the top of all of this that is just above the actual structural elements of the bridge itself that's supporting the vehicles that are traversing. So that is that. So I'm going to open it up for any questions that you might have, and I can try to back up to whatever slide we want if you want to look at any of the photographs of the illustrations.
Great presentation, Paul. I'm curious, they all look like they are very well maintained, and I'm wondering, is it the Oregon Department of Transportation that keeps up on these things? Are these county owned, or is it various? Or
I'm not totally sure. Some of them that are actually in communities and in the parks. I'm guessing that some are county and some are state. But I honestly don't know all of the details. I'm sure that the state is a participant in funding of maintenance just because these are historical elements.
mm-hmm.
But I really don't know for sure the details on it. And I know that, for instance, in the Chambers Railroad Bridge, which I can bring up online here if you want. I took pictures of it, but it was in such bad shape back in the summer of 2008 that it was barricaded off. They didn't want anybody to get hurt. And I just took a photograph of the end and the side as best I could. And they've since rebuilt it. They've totally rebuilt it. And they built it adjacent to the existing span location. And then they slipped it back across the creek. It's not a very long bridge, but they reused some of the elements, particularly the metal elements that had not deteriorated, but it's in beautiful new shape, and it's right there in Cottage Grove. So if you're passing through Cottage Grove, you can go see a real wood truss covered railroad bridge. My recollection, it's only about 40 or 50 feet long, so it's not actually as long as most of these.
Paul, Dick Stivers,
Yeah.
I don't know what you use to measure the bridges, but I had a lady come out and give me an estimate on cleaning my rain gutters. And she had a little gadget. It was about the size of a flip phone, smaller than a cell phone. And it was a laser. And, she'd point it up, it went into the roof there and measured off 57 feet. Something you might want to look into if you pursue any more of these.
Yeah, those I think came about, at least those that were affordable, after I was doing that. I'm familiar with what you're talking about. As a matter of fact, I play golf, and I just recently got a rangefinder, and they're pretty accurate. At least it indicates. It says, I read it. It says 85.3 yards, and so it sounds, but typically, when you're talking about components, you look on this picture here, you can measure between these particular elements, and they all repeat.
Yeah.
And those things that you can reach by the ground, I just take voluminous notes. And luckily, Nancy was there to help, and we put together a form, if you will, where you could say, okay, I'm taking this measurement, and then I take a photograph of the end of the covered bridge, and with the horizontal and what vertical information that I had, I could, using scale, could figure out what some of these other unreachable dimensions were. I did bring along a ladder, though, that sometimes that was helpful to reach some things.
These are beautiful. You should publish a little book.
Yeah, I thought about it. I've still got 24 more to draw up, though. I've got all the photographs done, but I haven't done the sketches for them.
Oh, primarily, what are the what kind of roofing material do they use? They use cedar shakes or what?
You know, it varied. I think I saw asphalt shingles, cedar shakes, and metal roofing, corrugated metal roofing.
Okay, it looked like most of them had at one time cedar shakes because it had that kind of inside roofing.
Sure, sure. With the spaced board type of a thing. Yeah, I'm pretty sure that most of them were way back when, and then they've subsequently, you know, plywooded over them and put asphalt shingles on them, or just continue to use the spaced sheeting and just put a corrugated metal roof.
Paul, why are there so many in that area? Were bridges like this common all over the place and they just got saved there, or was that some local?
Well, these are spread along the I-5 corridor, you know, from kind of just south of Portland. I think the one that's furthest south is actually down just well, maybe 20 miles west of Ashland. But there used to be 300 of them in Oregon.
Gosh.
Yeah, 350 are left. And so I think that, you know, generally there's folks that want to save them, you know, as I don't know how many are in Indiana, but, you know, that's a state that's famous for covered bridges, as well as some places in New England. But I was kind of astounded when we came across the fact that these even existed out west here. You know, I thought I was going to have to go to, you know, Indiana or Pennsylvania or, you know, that far, but no. Matter of fact, I think that the first time I ever passed through a covered bridge was in Indiana, going to a gravesite of one of my ancestors, because that's where they came from, northwestern Indiana. And I thought, oh, this is really cool. And then Nance and I came across this. Hey, did you know that there are umpteen covered bridges in Oregon? So we decided to take these little vacations and go and explore these things. So anyway, it was fun.
Paul, did you happen to go into any of the Lane County tourist bureaus? Because I know they used to have a driving map and a tour of Lane County covered bridges.
Well, I actually, let me see if I can, well, I have two 3-inch 3-ring binders that are filled with stuff that I gathered on the bridges. And as a matter of fact, right here in front of me is just a simple list that has where these are. And it says, for instance, you know, here's the Lowell Bridge. From Interstate 5, take Highway 58 east to Lowell. Alternately, from Unity, follow Jasper Lowell Road approximately 3 miles to Highway 58. Lowell is on the south side of Dexter Lake. You know, so you get this sort of information. You can get this information for all of them, not just Lane County.
Another one that's that you didn't mention, Paul, it's very easy to get to is Grave Creek Bridge. It's about 15 miles north of Grants Pass. You get off I-5 at Sunny Valley, and it's within a mile east of the highway. So it's very close.
Yeah, it's on my map there, and we visited it, and I just didn't do drawings for it. So, but I've got all the information for it and photographs. So yeah, you know, I probably overwhelmed you with all of the images here, but yeah, I just was kind of taken by these because they're nice architectural elements that speak to transportation back in the early part of the last century, you know, and you saw that there's dates on lots of these. Some of them, they don't actually have build dates for them. So be it. I mean, I don't know.
This would sure be fascinating on a layout.
Yes. And is actually, if anybody is interested in information on any of these, you saw that I've got drawings and photographs. You can contact me, and we can share some information if somebody wants to replicate one of these things. I think there's plenty of information, at least the ones that I have drawn up, to do it. And others, you can just work from photographs. I probably have at least a dozen photographs for every one of these bridges.
Well, thanks, Paul. And if you don't mind, I'm going to chatting with Burr Stewart here about maybe getting this your presentation online on the 4D YouTube site.
That's fine.
Okay, great.